Myself, Sanjay Utage, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technologies, Solapur. Today, we are going to discuss electric vehicles, learning outcome. At the end of this topic, student is able to understand the concept of electric vehicle, understand the importance of environmental friendly electrical vehicle than internal combustion engine vehicles. The internal combustion engine vehicles are these are nothing but the fuel engines. They require the fuel like diesel, petrol, CNG and so on. Brief introduction. An electric vehicle, also called an EV, uses one or more electric motors or traction motors for propulsion instead of traditional fossil fuel. It means that instead of using IC engines, okay, here they are using electrical vehicle that are being driven by the electric motors. It may uses DC motors or AC motors. First electric carriage was built in 1830s and the first electric automobile was built in 1891 in the United States. Types of electric vehicle: battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, fuel cell electric vehicle. For in this hybrid electric vehicle, it has got two types of sources. One is a regular fuel engine driven, and the another one electric motor driven. Electrical vehicles will play a pivot role in changing the environment and economy around the globe in the next 2 decades. It means that instead of using the fuel engines, nowadays all the vehicles are operated by electricity. So the demand of the fuel from the other country will be very much reduced. Why we need EV? Fast depletion of fossil fuel. For example, in India, we get the fuel maximum 75% of fuel we are getting from the Arab countries. Usage of EV will result in significant reduction in air pollution, that is carbon dioxide emission. As transportation accounts for one third of all energy uses, it indicates? It indicates that 66% of the total energy being used particularly for the transportation purpose. With rapid urbanization around the globe, electrical vehicle is the need of the hour to serve everyone. Currently, India has only 150 charging stations to charge the batteries of the electrical vehicle. Government of India has recently sanctioned setting up 2636 number of charging stations across 62 cities in India, which will reduce range anxiety to a considerable extent. Phasing out of combustion engine vehicle is at the initial stage to encourage purchase of eco-friendly electric vehicle. Many Indian startups and other manufacturers have come up with EVs for commercial usage and they have already hit the Indian roads. So you can see here components of an electric vehicle. This is electric traction motor shown at the center, front side center. Then power electronics controller that will decide the speed of the motor depending on the road condition or depending on the pedal position. Then next one is the DC to DC converter. This is also used to charge the auxiliary batteries or as well as the main batteries. Next is the thermal system, that is the cooling system. As usually in fuel engines we are providing the coolant for to keep the temperature minimum of the IC engine. Then there are some auxiliary batteries are there, then online charger is there, then charge port is there, and some other accessory shown. All electric vehicles, also referred to as battery electric vehicles (BEV), use a battery pack to store the electrical energy that powers the motor. The batteries are charged by plugging the vehicle into an electric power source. Although electricity production may contribute to air pollution, the US Environmental Protection Agencies categorize all electric vehicles as zero emission vehicles because they produce no direct exhaust or tailpipe emission locally. Key components of an all electric car: battery, all electric auxiliary. In an electric drive vehicle, the auxiliary battery provides electricity to power vehicle's accessories. Means the vehicle accessory includes the wiper movement, then window glass opening and closing, and some sensors are used. So all these are supplied with the auxiliary batteries, whereas the main battery provides the voltage to the electric traction motor. Charge port. The charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. DC to DC converter. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary batteries. Electric traction motor. Using power from the traction battery pack, this motor drives the vehicle's wheels. Some vehicles use motor generator that perform both the drive regeneration functions. Onboard charger takes the incoming AC electricity supplied via the charge port and converts it to DC power for charging the traction battery. It also communicates with the charging equipment and monitors battery characteristics such voltage, current, temperature, and stage of a charge while charging the pack. Power electronics controller. This unit manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. Thermal system, cooling system. This system maintains a proper operating temperature range of the engine, electric motors, power electronics, and other components. Traction battery pack stores electricity for use by the electric traction motor. Transmission electric. The transmission transfers the mechanical power from the electric traction motor to drive the wheels. How it works? Powered by fuel cells and an electric motor. Electric motors gets power from a controller which gets power from rechargeable batteries. Accelerator pedal hooks to a pair of potentiometer which are variable resistors that provides the signal of how much power to deliver. Each motor has two potentiometers for safety. Two types of motors, DC or AC. DC runs on 96 to 192 volts. AC is a three-phase motor that runs at 240 volts with a 300 volts battery pack. This is how it was. The pedal is shown on the left hand side. The position of foot will decide the position of the pedal. That will change the resistance of the potentiometer. The potential and in this way, change in the resistance will decide the how much power is to be delivered to the DC motor, and this has been carried out by the DC controller, which is excited with the batteries of 96 to 195 volts. DC is a simpler and less expensive, has a 20,000 watts to 30,000 watts motor and a 40,000 to 60,000 watts controller. Controller reads the setting of the accelerator pedal. The pulse power is more than 15,000 times per second. Okay, the same diagram is being shown over here. In addition to the previous diagram, there is a charger also shown below the auxiliary battery, which works on the low voltage, that is 12 volts. Same thing at the center, there is a controller. The controller will decide the output power delivered to the AC motor depending on the position of the pedal, and another 30 volt battery array is being shown over here. The output of AC motor is given to the transmission that will provide the motion to the wheels of the motor. Again, same DC to DC converter, battery pack, AC to DC converter, there is a grid, DC load, DC to AC converter, gasoline engine, motor, mechanical traction. This is a kind of a hybrid motor in which we are providing the motoring action through the electricity. Another one, the motoring action is also been carried out by the gasoline engine. How it works? Able to use any three-phase AC motor regeneration features. Controller creates three pseudo sine wave and needs to reverse the polarity of the voltage 60 times per second. Needs 6 transistors. Charging an EV. Pumps electricity into batteries as quickly as batteries will allow. Monitors batteries and avoids damaging them. Can recharge from any outlet. Average amount of energy the car can consume is 1.5 kilowatts per hour and can take 10 to 12 hours to fully charge. Can convert existing gasoline cars into electric cars at home. Mainly uses a DC motor and DC controller. Voltage is decided by owner, usually between 96 to 192 volts. Usually have a manual transmission. Use lead acid batteries. Converting to EV, remove the engine, gas tank, exhaust system and clutch. Attach the adapter plate to the transmission and mount the motor and controller. Find space to safely install the batteries. Wire the batteries and motor to the controller. Install accessories. Problems with the batteries. They are heavy, also bulky, have limited capacity, slow to charge, have a short life, and they are expensive. Environmentally advantages: environmental friendly, no tailpipe emission or local pollution, not entirely pollution free because they are charged from electric power grids. Gasoline powered cars produces 22 lbs of carbon dioxide versus 7 lbs for an electric car. Batteries can be recycled. Economic advantages: traveling 40 km on 5 kilowatt costs 33 rupees only for an electric car, while it costs of rupees 200 with gasoline cars. An electric car can be charged with a solar panel, generates many new jobs, less dependent on other countries for oil. Disadvantages: short battery life, long time to charge batteries. Batteries are expensive. More environmental friendly, more efficient energy use, no more paying outrageous price for gas, easy to use or convert to batteries, can be reused and recycled. Electric vehicles are generally powered by which out of the following batteries? Aluminum, lead acid batteries, sodium or magnesium batteries. The correct answer is lead acid batteries. These can be designed to be high power and are inexpensive, safe, recyclable and reliable. However, low specific energy, poor cold temperature performance and short calendar and life cycle impede their use. Hybrid vehicle. What is hybrid vehicle? Any vehicle which combines two or more source of power. Example, diesel electric, nuclear electric, gasoline electric. The two power sources found in hybrid vehicles may be combined in different ways, either in parallel or serial. Either one will allow the gasoline engine to shut down when it is not needed. Parallel hybrid. Gasoline motor batteries which powers an electric motor, both can power the transmission at the same time. Electric motor supplies the gasoline engine. Series hybrid. Gasoline motor turns a generator. Generator may either charge the batteries or power an electric motor that drives the transmission. At low speed is powered only by the electric motor. These are the references. Thank you.